Okay, this will be the first lesson that I'm going to be trying to videotape. It will be for Chapter 7, Lesson 7, and the Common Core State Standard is to apply and extend previous understandings of multiplication and division to multiply and divide fractions. This will be found on page 147 of your non-colorful homework practice book. That being said, the main difference between today's lesson and yesterday's lesson is that now we're going to be multiplying with mixed numbers. And a mixed number is a number where there's a whole number and a fraction. So you can see here, there's a whole number, 2, and a fraction, 1/4. Now, we can't just do 2 times 1 and 1/4 times 1/2. It won't work that way. So we're going to represent these in two different models or pictures. The first one we're going to do is using a grid, and then the second one we're going to do is when we create our own rectangles. So let's take a look at what they started to fill in. Let each square represent 1/4 unit by 1/4 unit. When you see that by, it's almost like saying 1/4 times 1/4. So when you look at that word by, you're looking at 2 dimensions. What makes this 2 dimensions is that you're not just going left to right, but you're going left to right and up and down. So when they're saying 1 square, each square, and units by unit, they're talking about, if you to just look at this 1 square right here, 1 unit meaning 1/4 going this way, and then the other 4th going this way. Let each square represent 1/4 unit by 1/4 unit. Means if you were to look at just 1 square, this length is 1/4 and this length is 1/4. This is a 2-dimensional object because it's going up and down and left and right. Likewise, because it's a square and each unit is the same, this length is going to be what? Correct. 1/4. What is this unit going to be right here? Correct. 1/4. What is this unit, this length going to be right here? 1/4. What is this length going to be right here? Correct. 1/4. And this last length. Now, as I'm saying last, I'm saying that because that's where this larger rectangle begins and ends. What I want us to do right now is to count up how many 1/4s we have. So, 1, 2, 3, 4, 5, 6. We have 6 squares here. And if you were to add 1/4 plus 1/4 plus 1/4 plus 1/4 plus 1/4 plus 1/4, you'll end up getting 6/4. That is your total right there. Now, if we were to simplify 6/4, let's see what we would get. And I want to see if you guys can make any predictions, but when the numerator is bigger than the denominator, that means that the answer is what? Correct. More than 1. So if it's more than 1, we're going to change it into a mixed number, a number that has a whole number and a fraction. By doing that, you're going to take the numerator, put it inside the house, and then you're going to divide by the denominator. So 4 goes into 6. You ask yourself, buddy, what 4 times what number gets close to 6 without going over? Well, let's look at it. 4 times 1 is 4. 4 times 2 is 8. If our target is 6, we're going to use 4 times 1 equals 4. Because 4 times 2 equals 8, that's too much. We only have 6. So, buddy, 4 times what number gets close to 6 without going over? 4 times 1. The 1 goes up here. And we subtract the 4, which was your answer right here. And you have 2 left over. Now what do? Because we're not working with decimals, we're not going to put a decimal 0. Instead, this is going to be our numerator. And this is going to be our denominator. Now, once we get 1 and 2/4, you ask yourself, buddy, can you simplify that any more? And the answer is yes. So if you look at 1 2/4 with me, what number can you divide by top and bottom that goes into 2 and 4 and still give you a whole number? If you divide by 2 over 2, 2 divided by 2 will be 1. 4 divided by 2 will be 2. So your final answer is you keep the whole number, 1. And then 2 divided by 2 is 1. 4 divided by 2 is 2. Look at where we got this 1/2 from. 1 1/2. 1 1/2. What they did here was that if you're letting each unit be represented as 1/4 by 1/4, you're going 1/4, 1/4, 1/4, all the way until you get 1 1/2. 1 1/2 is the same as 6 over 4. 6 over 4 is the same as 1 2/4. 1 2/4 is the same as 1 1/2. So you could see over here, through pictures, 1/4 plus 1/4 plus 1/4 plus 1/4 plus 1/4 plus 1/4 is 6/4. It's the same as this, this, and this. Now guess what this will equal? And if your prediction is 2 1/4, that is a great prediction. Let's see if it's correct. 1/4 plus 1/4 plus 1/4 plus 1/4, 1/4, 1/4, 1/4, 1/4, and 1/4. Now why do we keep repeating this 1/4? Because it said right here, each square represents 1/4 unit by 1/4 unit. You'll see in number 2 how we won't be using the number 1/4 because the directions themselves will change. So do know that this number can change depending on the directions. Now let's add them up. 1, 2, 3, 4, 5, 6, 7, 8, 9. This is 9 over 4 as a total. Now just like we did here, let's see if 9 over 4 is going to equal the other number that we have. Let's see if it equals 2 1/4. How can we find that out? Well, if the numerator is bigger than the denominator, then the number is more than 1. So let's divide. The numerator 9 goes inside the house. Then you ask yourself, buddy, 4 times what number gets close to or equal to 9 without going over? Let's look at our 4's here. Now, 4 is not close enough to 9. 8 is closer to 9, and 12 is too much. So this time we're going to use 4 times 2 equals 8. Now the 4 times 2, buddy, 4 times what number? 2. Gets close to or equal to 9 without going over, and equals 8. We're going to subtract these two numbers. 9 minus 8 is 1. Now if we were doing decimals, we could put a decimal here, add a 0. However, we're doing fractions. So the 1 is going to become the numerator, and this is going to remain as your denominator. And look at how this is 2 1/4, and we don't have to simplify it. So what they did here was they represented 2 1/4 and 1 1/2. That's all they did so far. So your first step is to draw a picture that has 2 1/4 in its length and 1 1/2 in its width. Once you get that, that's the first step. Are there any questions on the first step? Okay, now the second step. You're going to count all the squares within this square. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54. Okay, I counted 54. Now, that will be your first answer for here. There are 54 squares that cover the diagram. And what they mean by the diagram is the rectangle that you drew that was 1.5 by 2 1/4. Now, this is where it gets tricky because they're saying each square is how many square units. I will tell you, do not get tricked like Miss Tolentino did the first time she did this problem. When I saw that, I thought I was reading the directions. It goes 1/4 goes right here. Remember, class, we're doing 1/4 unit by, which means multiply 1/4. So when you're talking about each square in terms of square unit, you have to multiply these two. You have to do 1/4 times 1/4 to get this answer right here. So what you're going to do is multiply those two numbers. 1/4 times 1/4. And remember, when you multiply, you don't need to common denominators. You just multiply the numerators and the denominators. 1 times 1 is 1. 4 times 4 is 16. 1/16. Let's review what we did so far. Step 1 was to draw a diagram that was 2 1/4 by 1.5. Step 2 is to count the amount of squares, and there are 54 squares. Step 3 is to find out each square unit and keep in mind that it's 1/4 by multiply 1/4. 1/4 times 1/4. Okay, we're almost there now. To find the area, all we're going to do is multiply the amount of squares by the 1/16. So we're going to multiply 54 times 1/16. Now this is going to look a lot like yesterday's lesson. Remember, 54 is the same as 54/1. So you could do 54 times 1, numerators times the numerators, and 1 times the 16, denominators times the denominators. And from here, if the numerator is bigger than the denominator, you could put that inside the house. So when you're getting to 54/16, the 54 can go inside the house, divided by 16. Now, Miss Tolentino may not know her 16's multiplications too well, so you could just do it on the side. If you try 16 times 2, 2 times 6 is 12, carry the 1. 2 times 1 is 2, plus 1 is 3. 32 is close to 54, but let's double check 16 times 3 just in case. 6 times 3 is 18, carry the 1. 3 times 1 is 3, plus 1 is 4. 48 is close to 54, but let's try the next number. After 3 is 4. Let's try it just in case. 6 times 4 is 24. 4 times 1 is 4, plus 2 is 64. Uh-oh, 64 is bigger than 54, so what am I going to use? 16 times 3. So, buddy, 16 times what number gets close to 54 without going over? 16 times 3. 16 times 3 is what? 48. And then your remainder is 6. What does the remainder become? It is your numerator, and this is your denominator. Now, if you simplify that, you could divide by 2 on top and bottom, and your final answer will be 3 3/8. Go ahead and review that first problem before we start the second one. So, how we got from that 3 3/8 is you divide by 2 on the top and bottom. 6 divided by 2 is at 3. 16 divided by 2 is at 8, and the whole number stays the same. So, this is kind of the map of what we're going to be doing, but it's better when they don't have all the answers for you because they'll make more sense. So, I'm going to take a break right here. If you need to, you could look back at number 1. All right, now we're back, and we're going to start number 2. Let's read the directions for this. Let each square represent 1/3 unit by 1/3 unit. So if we're talking about one square right here, this square is 1/3, and this square is 1/3. Now, unlike the other one, this is going to be a lot faster because we'll go up and down first. This number is going to go up and down. So we need 1 2/3 up and down. What is 1 2/3? How many boxes would you need? Let's change this to an improper fraction. If you're to think about it as an improper fraction, there's two ways you could do it. When you're looking at 1 2/3, you could think to yourself, what is 1? 1 is, if you're talking about the whole number, 3/3, correct? Because if your denominator is 3, and then if your numerator and denominator are the same, that's 1. So 3/3 is the same as 1, and then you have your 2/3 and your 2/3. How much do you have? 3 plus 2 is 5/3. So all you'll need are 5 boxes. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So it ends here. 5/3 is the same as 1 2/3. Another way to do that is saying 3 times 1 is 3, plus 2 is 5/3. So we have 5 boxes going this way. What's our second step? We need to find out how far this goes going left and right. So how far is our width going over here? We're going to do the same process. If we're doing 2 1/3, 2 1/3, we just say to ourselves, what is 2? If our 1 unit is 3, how many do we need if we want to have 2 of them? If we have one piece that's split into 3, you have 1, 2, 3 pieces. But remember, you have 2 holes split into 3. How many pieces do you have? 1, 2, 3, 4, 5, 6. So 6/3. Then you have your extra 1/3. How much do you have altogether? 7/3. So when we're doing the lines going this way, you'll only need 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, and it stops here. Because 2 is the same as 1, 2, 3, 4, 5, 6/3. 2 is the same as 6/3, and then with your extra third, 6 plus 1 is 7/3. Another way to do it is 3 times 2 is 6, plus 1 is 7/3. Now we just finished drawing our diagram. Now this is what they mean when they say to draw your diagram using a grid. A grid is like these lines here. That's a grid. Now let's see how many squares. Oh, so yeah. So step 1 was draw your diagram. It has to be 1 2/3 by 2 1/3, with each of these being 1/3. Second step is to count your squares. So let's count your squares. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35. So you have 35 squares. Your second step is to see how many square units you have. Remember, it's the 1/3 unit by 1/3 unit. So for your second one, you have to do 1/3 times 1/3. So it's a 1/9 unit squared. So you have 35 squares at 1/9 unit squared. all you have to do is multiply these two numbers. This one we got by how many squares they are. This one we got by multiplying these two numbers. When you multiply this is yesterday's lesson. You just put it over 1. 35 times 1 is 35. 1 times 9 is 9. What's really cool about multiplication is all you have to do are the numerators times the denominators. You don't have to worry about much else. Right. Now, here's your 35 over 9. When the numerator is bigger than the denominator, that just means your answer is bigger than 1. So you can put the thing inside the house. And you're going to ask yourself, buddy, 9 times what number gets close to 35? If you don't know your 9s, you could list them out. 9 times 1 is 9. 9 times 2 is 18. 9 times 3 is 27. 9 times 4 is 36. You're not allowed to go past 35, so this is too much. You have to use 9 times 3 equals 27. So, buddy, 9 times what number gets close to 35 without going over? You're going to use 9 times 3. What does 9 times 3 equal? 27. And you'll get 8. That 8 is your numerator, and this is your denominator. You make sure that you can't simplify any farther than this, and when you look at 8 and 9, there is no number that can go into both of them, so that will be your final answer. 3 and 8, 9 square units. Okay, now this is the second model that we're going to be showing. So, if they're asking you to use a grid to find the area, that's how to do numbers 1 and 2. Numbers 3, 4, and 5 are asking for a whole nother picture, a whole nother model. And the one that they're looking for is an area model. Just looking at the space provided here, I know there's not going to be enough paper. So what you can do and what I'm going to do is I'm going to do it on another piece of paper. First step I'm going to do is write that problem out. Number 3 is 1 1/8 times 2 1/2. 1 1/8 times 2 1/2. Now, I highly recommend that you use another piece of paper because you will not have enough room to attempt to do it on the space provided. I'll give you a second to go get your paper, and you could also pause the video if you need to. All right. That being said, you're going to draw out a box. This one is going to be much more like the distributive property and something we did with decimals, if you could remember that far back. Now, what we did when we were working with decimals and even with some whole numbers is we split the number apart. So when we're looking at 1 and 1/8, we could be saying 1 and 1/8. Because 1 plus 1/8 is 1 and 1/8. Okay? So I broke this up to 1 and 1/8. The same way that I broke this up, we're going to break this second number up. So what do you think I'm going to put here? It's going to be the whole number. What's the whole number? 2. Now we're going to take that fraction and we're going to put it to the side. So we're going to think of it as 1 and 1/8, 2 1/2. We're going to divide this up into 4 smaller boxes and smaller math problems. In this first box, we're going to multiply the length and the width. So when I trace over it, I could see that I'm tracing over the 1 times the 2. 1 times 2 is 2. And that's what this answer is right here. So I took the length and the width, which is 1 and 2, and I multiplied it. 1 times 2 is 2. So this answer right here is 2. We're going to do the same thing for this. We're going to take the length. Now, this length is the same as this length right here. So this is 1 times the width here, The width here is 1/2. How do you do 1 times 1/2? You change the 1 to 1 over 1, and you multiply the numerators. 1 times 1 is 1. 1 times 2 is 2. So this answer is 1/2. This answer is 2. This answer is 1/2. Keep in mind, the way I got this 1 is from this one right here, 1 and 1/8. The way I got this 2 and 2.5 is from here, 2, 2.5. We're going to do the same thing, but for the next box. And we're going to look at the length, which is 1/8. And we're going to multiply it by the width, which is 2. Keep in mind that 2 is the same as 2 over 1. And we're going to multiply the top numbers, the numerators, by the denominators. 1 times 2 is 2. 8 times 1 is 8. But this answer is not done. You can simplify. What number can you divide on both top and bottom? Good, 2. 2 divided by 2 is 1. 8 divided by 2 is 4. So this final answer is 1/4. 2/8 is also true, but 1/4 is a better answer. Now we're doing the last section. This, 1/8, times this, 1/2. 1/8, which we got from the up and down length, and the width, 1/2. Do the numerators times the denominators. 1 times 1 is 1. 8 times 2 is 16, and we can't reduce that. Once we get all 4 of these answers, the last step is to add them all up. Be very careful that you're putting the whole numbers on one side and the fractions on the other. So 2 is a whole number. That's going to go on the left side. 1/2 is a fraction. It's going to go on the right side. 1/4 is a fraction. It's going to go on the right side. 1/16 is a fraction. It's going to go on the right side. And we're going to add them up like I said. Remember, when you're adding, the denominators have to be the same. When you're subtracting, the denominators have to be the same. It's only when you're multiplying that it could go quick and easy. Numerators times the numerators, denominators times the denominators. But when you're adding, what you're doing here, these denominators better be the same number. Do we have the same denominator? No. So we need to look for a common denominator. If you're looking for a common denominator, for 2, 4, and 16, you can list the multiples. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 4, 8, 12, 16, 20. If you're wondering how I know these so quickly, just think of your math facts. Or you could do 2 plus 2 plus 2 plus 2 plus 2 to get you to each step. Or you could just do 2 times 1, 2 times 2, 2 times 3, 2 times 4. Likewise, you could do 4 times 1, 4 times 2, 4 times 3, 4 times 4, 4 times 5. Or you could just keep adding 4 plus 4 plus 4 plus 4 plus 4. The sooner you know your math facts, the faster these will be. 16, and I know that the next one is 32. I know the next one's 48. Now I'm going to stop showing off there. This one, if you don't know them, you could write them on the side. 16 times 2, 32. 16 times 3. The faster you know your math facts, the faster this will be. Now keep in mind that this one has both 4 and 4, but there's no 4 here, so we can't use that. This one has both 8 and 8, but there's no 8 here, so we can't use that. Finally, a 16, a 16, and a 16. So our smallest common denominator is going to be 16. Everyone here is going to have a denominator of 16. Everyone here is going to have a denominator of 16. Everyone here is going to have a denominator of 16. Now, look at this arrow right here. How did you get from the circled number to that denominator? 2 times 8 gets you 16. If you need help, if you list it out here, you could just do 2 times 1, 2, 3, 4, 5, 6, 7, 8. 2 times 8 is 16. So if you list it out, that could help. If you do that to the bottom, you better do that to the top. I got the 8 by knowing that 2 times 8 is 16. So 1 times 8 is 8. This first answer is 8 over 16. I'm going to do something similar for the 4. How did you get from the 4 to the 16? If you know that 4 times 4 is 16, that's good. If not, you could use your cheat sheet here. 4 times 1, 2, 3, 4. 4 times 4 is 16. So what do you think I'm going to do to the top? The same exact thing I did to this one. Not what I did on top on this old problem with the 1/2, but what I did to the circled one. If I circled and put times 4, I'm going to times it by 4 on the one right next to it. 1 times 4 is 4. Now we're on the last step, 16. 16 times 1 is 16, and if that's what I did for the denominator, that better be what I do to the numerator. 1 times 1 is 1. Adding that all up, 8 plus 4 plus 1. 8, 9, 10, 11, 12, 13 is 13 over 16. And don't forget our whole numbers, 2. There's no other number in front. So your final answer is 2 and 13 over 16. And what you could do here is put the answer as 2 and 13 over 16. As long as you staple this onto this work. If you lose this work or you don't staple it, you're going to get a check minus. So make sure to, if you're to put just 2 and 13/16, you make sure to staple this work onto it or else it will not be full credit. All right.